Good evening, everyone. Oh, sorry. Good evening, everyone. Welcome to the second live interaction session for the course Technologies for Clean and Renewable Energy Production. So, as usual, let's just wait for a few minutes for others to join before we begin our session for today. So, I think we can start our session. So, let me just share my screen. So, here. I hope my screen is visible and I'm audible. So let's start our session for today. So, good evening, everyone. Welcome to the week 2 live interaction session for the course Technologies for Clean and Renewable Energy Production. This course is offered by Professor Prasenjit Mondal sir from the Department of Chemical Engineering, IIT Roorkee, under the NPTEL SWAYAM program. Myself, Pratyumnan, a PhD research scholar from the Department of Chemical Engineering, IIT Guwahati. I am one of the course team members who will be responsible for conducting the live interaction session every week. So let's begin our session today. So in the last live interaction session, we basically had a brief introduction towards what is renewable energy and the technologies that we use for this clean and renewable energy production. So initially, we first started with the basics of energy scenario and how energy is basically an indicator for its country's development. I hope you are able to recollect the concepts of what we discussed. And then we discussed about how coal is used as an energy resource and how we can use coal for energy production. And then we also discussed about the cleaner ways to use coal for energy production. So in today's week 2 session content as well, we continue our discussion with our central focus on coal. So first we use gasification and then we go for direct liquefaction of coal. So these are the two different ways through which we can obtain energy from coal. I mean, that will be the scope of the course, or so you can say that week's 2 content will be focused on gasification and the direct liquefaction of coal. So in case of gasification, I hope you guys remember like in the last live interaction session also, I just gave the basic difference between combustion and gasification. Anyone who is here who is able to recollect this? Anyone? What is the difference between gasification and combustion?
Combustion is like completely burning of fuel with like very much supply of oxygen, and gasification you like do partial like oxidation.
Yes, so basically the difference comes with the oxygen to the fuel ratio. In case of combustion, if you see, you use excess of oxygen for the complete burning of the fuel that you take. Whereas in case of gasification, you provide only a controlled amount of oxygen, so for the gasification process to occur. Whereas in case there is another method which is called pyrolysis. In that case, if you see, you actually supply only very deficient amount of oxygen to the system. So basically, depending upon the ratio of the oxygen to this fuel ratio, a process can be classified, or a thermal conversion routes can be classified as combustion, gasification and pyrolysis. So for more easy understanding, you can actually have a look at this table. So as you can see, depending upon the O2 to the coal ratio, that is the weight to weight ratio, or also you can define this as the term R. If R value is greater than 2.5, then this process is going to be called as combustion. If the value of R is within 0.68 to 2.5, it is called gasification. And if R is going to be less than 0.68, it is going to be called as pyrolysis. So this table was actually adapted from the, what do you say, from the lecture slides. So as I always say, please have a look at the course content, because there things will be discussed more in detail. Here we will have only a brief overview of what was discussed in the course. So kindly have a look at the course content as well. So the thing that I wanted to emphasize here is, it's not just about the oxygen to the cold ratio, but as we vary the oxygen to the cold ratio, the combustion products or products of the combustion, their composition is also going to be varied. So suppose if you have a value of R greater than 2.5, the composition is going to be a mixture of oxygen, water and carbon dioxide. However, if the value of R gets decreased, or you can, in another way, if you say that if you are going to supply a controlled amount of oxygen to the system, the composition of the product is going to change. So if you see, the carbon monoxide percentage increases in case of gasification. Whereas if you go for pyrolysis process, you can say that the solid carbon content is there in case of pyrolysis method. However, the same carbon content in case of gasification and combustion is very limited, or you can also say it is almost negligible. So gasification as such, so today since our focus is only on gasification, you can actually define the gasification as a process by which the carbonaceous feedstocks is converted to combustible gases, either in the supply of oxygen or through or with the help of steam. So there are two ways in which you can convert this carbonaceous feedstock, or you can say coal, to combustible gases. One is either through using oxygen, or you can say controlled amount of oxygen or partial oxygen, and the second method is going to be through the help of steam. And whatever the gases that gets produced through this process, it is called as syngas. Syngas, the full form is also known as synthesis gas. So if you use oxygen, the gas that is going to be produced is called syngas. If you use air, since the amount of nitrogen is going to be high in case of air, the gas that you gets produced as the product, or you can say the produced gas, is also called as producer gas. So depending upon the fuel that you use, whether depending upon the type of that gas that is used, whether it is oxygen or air, the produced gas is going to be different in terms of composition. Due to that particular difference, their names are also going to be different. Like one is going to be called as a syngas, and the other one, and in case if the nitrogen content is going to be more, it is called as a producer gas. So depending upon this, the heating value of these gas. So the major reason why we are talking about this gas is because along with this gas, you're also going to get some amount of energy. So depending upon the type of gas that gets produced, the energy content is also going to be varied. So in case of syngas, if you see, the heating value is going to be more compared to that of the producer gas. So any guesses or idea on why syngas has more heating value compared to that of the producer gas? Anyone? Yeah. Why syngas has more heating value compared to that of the producer gas? Yes, it's something that you need to think from the perspective of the air compositions.
Maybe because of inherent nitrogen.
Inherent.
Nitrogen.
So that's right. So in case of if you see the composition of syngas and composition of the producer gas, so let me just write that down. So let me just move this here. So if you see in case of syngas, so the composition of syngas is going to be majorly carbon monoxide plus hydrogen gas. So both of them are going to comprise about 60 to 90 percentage of the combustible gas that is going to be produced. So 60 to 90 percentage of the produced gas contains CO plus H2. Whereas in case of producer gas, it is going to be CO plus H2 plus N2. So CO and H2 comprise only of 30 to 40 percentage, whereas your N2 comprises of 45 to 55 percentage. So let me just make it here, 30 to 40 percentage. Here it's going to be 45 to 55 percentage. So producer gas is going to have more amount of nitrogen compared to that of the syngas. Again, here 60 to 90 percentage is CO plus H2, The rest, the rest 30 to 10 to 30 percentage is basically for the other kind of gases. So they are going to be present in smaller quantities. So majorly the produced gas, in case if you use air, in case if you use oxygen, it's going to be CO plus H2. If you're going to use nitrogen, it is CO plus H2 plus nitrogen. And the nitrogen quantity is going to be 45 to 55 percentage. Since the nitrogen gas is actually inert in nature, as somebody rightly said, they are not going to contribute to the heating value of heating value. So since they do not contribute to any heating value, the final heating value of the produced gas is going to be low in comparison to that of the syngas. So the major so if you exactly want to pinpoint on the answer, it is basically the presence of the nitrogen gas, or you can say the inert nature of the nitrogen gas is what makes the producer gas have a low heating value in comparison to that of a syngas. So this is about the concept of syngas. So here, if you see, as I said, you can use both oxygen as well as steam. So based on the kind of um, so based on that, whether oxygen or the steam is used, the products is going to actually vary. In case of if you see, in case of using oxygen, in case of the gasification of the volatiles, the carbon compounds, when it's going to react with oxygen, it's going to generate carbon monoxide plus hydrogen gas. Whereas if you are going to react it with steam, again it's going to produce hydrogen gas plus carbon monoxide. However, the stoichiometric quantity of the hydrogen gas that gets produced through this is going to vary. So majorly the gasification process as such can be, or as such it comprises of the following steps. So first one is drying, second one is devolatilization, third one is reduction, fourth one is oxidation, and fifth one is ash cooling. So as such as any process unlike any process, gasification is basically is comprised of a series of process starting from drying, devolatilization, reduction, oxidation, and ash cooling. So based on this amount of gas produced, I mean the syngas, the amount that gets produced can actually be calculated. So we will come back to that particular problem in quite some time. So just remember that we are not just interested in knowing the composition, we are also interested in knowing how much amount of the energy that gets produced from the syngas, and what is the flow rate of the syngas that gets produced. So based on that, we will be able to solve few problems. So the factors that influence this gasification process, number of factors are there which actually influences your gasification reaction. One is, it is about the type of feed injection. So if you see the gasification process, it can actually take place in different kind of systems. So you can either go for co-current flow, counter flow, or you can also go for parallel flow, counter flow, and another one is cross flow. So depending upon the type of flow arrangement that we take for the feed injection, the gasification process will be influenced, and that will directly influence the amount of syngas that gets produced from the system. Next is your gasification agent. By gasification agent, we mean whether we use oxygen or we use steam. Then we go for type of heating. Again, gasification is not just conventionally we increase the temperature, but again there are also modern techniques like plasma gasification, where we actually use plasma to generate heat, and that actually burns the coal and produces the syngas. After that you have this temperature range, and after that you have the pressure range. So the both the pressure as well as the temperature also has an effect on the amount of syngas that gets produced, or and the composition of the syngas, as well as the energy that the syngas carries with them. So majorly the advantages of the gasification, if you see, it is basically used for reducing the CO2 emission. It's basically produce accurate combustion control, high thermal efficiency, and compact equipment requirements. So let me just quickly jot down that list here. So this is something that you need to actually keep in your mind, because sometimes there are chances that these kind of questions may come up in your assignment. So please have a look at the advantages and the disadvantages of each of the process as we discuss, because we need to have an idea on which particular process may be useful for a certain type. What are the advantages and the disadvantages for a certain process, so that we can easily judge easily judge which process we can actually use while going for energy production from coal. So first one is reduce the CO2 emission. Second one is accurate combustion control. Third one is high thermal efficiency. Fourth one is compact equipment requirement. So these are the basic advantages of the gasification process. Again, this gasification is usually carried out in different types of gasifiers, such as fixed bed gasifier, fluidized bed gasifier, moving bed gasifier, and entrained bed gasifier. Each of these types of gasifier has their own advantages and disadvantage. So depending upon the type of gasifier that we use, we can actually have an influence over the temperature as well as the pressure that is required for the gasification process. So in case of the fluidized bed, if you see, since the bed over there is going to be in a motion, that's why we call it as a fluidized bed. The heat and mass transfer happens more efficiently, and hence lesser temperature may be required for the gasification process compared to that of your fixed bed. So fluidized bed requires less temperature for gasification compared to fixed bed. Again, if I ask how does it really affects the process, anyone who will be willing to let me know, like, it's okay, fixed bed actually requires less temperature for gasification compared to fixed bed, but how does it actually going to help me, or what is the practical advantage that I am going to get by using a fluidized bed in comparison to that of a fixed bed? Anyone? Why is fixed bed more advantageous compared to fluidized bed? One reason is less temperature is required for the gasification process. But how does it going to give any sort of a practical advantage to me? I mean, as an engineer, why would I be interested in lowering the temperature? How it would actually help me? How would using, I mean, why will that why will lowering the temperature requirement for a fluidized bed will help me? Simple, it's about the cost that is involved. So when you are actually going to use a, when you are actually going for a high temperature process, you are also, I mean, to maintain, to get to that temperature, you're supposed to burn more fuel and you're supposed to invest on that fuel. So by lowering the temperature requirement, you are actually going to reduce the of cost that is going to be involved in the process. So for every, I mean, this process is as such, if you see in an industrial scale, for every 1 degree temperature that you're actually going to reduce and make the process more efficient, it's actually translate to almost millions of money. So it helps to make the process more cheaper and more profitable compared to the fixed bed reactor. So fluidized bed reactor basically operates at less temperature compared to a fixed bed reactor. And how does it going to practically benefit me? It basically lowers the cost that is involved in the process. Again, after these kind of gasifier, these are from the conventional perspective. The recent development in the technologies, we have this plasma gasification process. So it's a type of an advanced gasification technology where we try to use plasma for the burning of coal to obtain the energy. So what actually happens here is voltage is applied, a very high voltage is applied to be specific. That high voltage basically energizes the electrons which collide and ionize and dissociate and excite the ambient molecules and then creates a spark. So a huge amount of heat energy is released upon applying of this high voltage, which is basically useful for burning of the coal to basically produce the energy. So in case of the plasma gasification process, the efficiency of the process is going to be more. You are going to make the process more efficient, more cheaper, and hence it is basically one of the growing technologies which is being rapidly used in the coal plants for deriving energy. So any questions related to the syngas? Or shall we go towards how do you recover energy from the syngas? Because that is again another section. Here you produce a syngas, energy is there within that gas. But we need to come up with the technologies where we can actually extract that energy from the syngas before I let it out to the atmosphere or use it for some other purpose. Anyone, any doubts? Okay, so as I said, syngas is going to contain energy and it becomes our, it becomes our, it's our responsibility, or you can say that's where our role comes. We need to actually extract the energy from syngas. So basically what we need to do is, when we say extract the energy, we need to basically lower its temperature. Again, as I said in the last session also, you cannot actually quantify heat directly. Heat can be only quantified as a function of temperature. So if you increase the temperature, you say that the particular substance has gained heat if there is an increase in its temperature. In case if it has lost heat to the surroundings, you say that you observe that the object has, the temperature of that object has reduced. So you can quantify heat only as a function of temperature. So by cooling down the gas, we can easily extract the heat that is produced in the syngas for the for our human use. So basically we need to produce energy so that humans can use. So the syngas, if you cool down those syngas, you can actually extract the energy for your applications. So how you are going to do that lowering of the energy or cooling the syngas? Through two ways. One is using a quenching technique, and another one is basically using a boiler method. So in case of boiler method, what happens is you get a raw hot syngas, and then you basically make that syngas enter inside a high pressure steam boiler. So once the syngas enters inside the high pressure steam boiler, the syngas expands and it basically transfers its energy to the steam, and then the steam basically rotates the steam turbine, and then the electrical energy is extracted. In case of the quench mode, what actually happens is this hot raw syngas is quenched using shock cool, or you can say this raw hot syngas basically enters into a quench ring where it is shock cooled by water. This cooled syngas leaves as a substrate, and then the energy that is absorbed by the water is taken, that hot water is taken to a is taken to a high pressure steam boiler where it again rotates, where the turbine again rotates to produce the electrical energy. So two methods, one is quench mode of operation and another one is boiler mode of operation. Both method you basically quench, or you can basically say you lower the temperature of the syngas by using water. So in one case the water enters inside the, in one case what happens is the hot raw gas enters inside the high pressure steam boiler, and then the steam rotates the steam turbine to produce the energy. In the second case, that is your quench, what actually happens is the hot raw gas or hot raw syngas is basically enters into a quench ring where it is shock cooled by the water. That steam then moves to the steam boiler where it rotates the steam turbine to produce electrical power. So this is about recovering heat. There is another one parameter that we need to discuss. So before you actually let the syngas out, you need to actually remove the particulate matters from the syngas. So as I said, it's going to consist of carbon monoxide, hydrogen gases, other kind of particulate matters. So as per, so in order to make the process more sustainable, or you can say in order to make sure that this syngas do not, or the flue gas do not contaminate the environment, we are supposed to remove the particulate matters that is present in the syngas before we let the syngas, or you can say the flue gas, out to the atmosphere. So usually for this we use a two-stage water wash process wherein you wash the syngas with quench pipe and a packed towel. So using the quench pipe, 95% of the carbon gets removed, and in the scrubber you use a circulating system to remove the particulate matters from the syngas. Apart from that, you can also go for solvent based adsorption techniques using MDA, select salt, and and methanol, where you can use physical absorption and chemical absorption techniques to remove the particulate matters from the flue gas before you let the clean air into the, or you can say the clean gas into the atmosphere. Apart from that, you also need to do desulfurization process. So wherein you basically treat the harmful gases, and then obtain sulfur from them before letting the syngas out into the atmosphere. So we will basically discuss that while we discuss about some of the problems towards the within another few minutes. So the syngas that gets produced, either you have two choices. Just a second. Okay. You have either two choices. One choice is basically you let it out into the atmosphere. There is another one choice wherein you can actually use the syngas for different purposes. So any guesses or any ideas on what, or you can say how can we convert the syngas into useful products? Anyone? Yes. Anyone? How can you use syngas to produce chemicals, or what kind of chemicals can you produce using syngas? There is one famous synthesis technique. So there are multiple ways in which you can actually use them. So either you can use the syngas to produce different chemicals, like you can say, so one is the most famous technique is the Fischer-Tropsch synthesis. So in case if you are not aware about that, then please go and have a look at the internet. So you can say what kind of chemicals are basically produced through Fischer-Tropsch synthesis, and you can also see what kind of or how that process actually happens. Then you can also produce other kind of methanol derivatives such as ethylene glycol, ethylene, propylene, DME, and then you can also go for some sort of acrylamide, polyacrylamide, PAM, and you can also go for substitute natural gases, and you can use this again. Syngas as such for electricity and steam is their main focus. Apart from that, you can use the syngas for all these. Either you can do Fischer-Tropsch synthesis, or you can actually go for the methanol derivatives like ethylene, propylene, DME, PAM, other varieties of them. Or you can also use this as a substitute for a natural gas, and then the hydrogen gets that produced using the syngas. It can be used as a source. It's a very good source. Hydrogen energy, I think probably it's basically becoming, it's actually booming field wherein they want to use hydrogen as a source of energy for everyday use. So again, in the recent days also, it was there everywhere where people, when there was what do you say, when there was a shortage of LPG, people, the many researchers actually focused on how to use hydrogen gas as a source of energy, because LPG, at that time there was a crisis. So due to that, we basically there were lots of discussion on why can't hydrogen gas be used to replace LPG in a longer term. So again, that hydrogen gas that gets produced as a part of the synthesis gas is a valuable source of energy which can be used. Apart from that, you have electricity and steam, and then other than that, you have your other kind of derivatives or the chemicals that you can produce from this synthesis gas. Again, you need to do a lot more modification or process to obtain that, but it is possible. So till here we discussed about gasification of the coal. Now after this we move towards the direct liquefaction of the coal. So any questions in related to gasification? Okay. So what do you actually mean by liquefaction of the coal? I think the name as such suggests liquefaction. Anyone? So you are going to actually produce some kind of liquids from the coal. So that's exactly what you actually mean by liquefaction of the coal. And how you are going to do that? What you are going to do is, to the hydrogen deficient organic structure, or basically the coal, you are basically going to hydrogenate them by adding hydrogen, and then you are actually going to break down the structure until you get a liquid of that material. So what you're typically going to do is, you're going to take a coal, a solid form. That particular coal is deficient in hydrogen, so you're going to hydrogenate that coal using high temperature and high pressure in the presence of catalyst and hydrogen gas. Yeah, and then you're going to obtain coal liquid. Once you're going to get the coal liquid, since that coal liquid basically is a crude form, so it's going to contain many different components. You're going to do a distillation of that in order to obtain different kinds of oils from that. For example, it is going to be gas oil, synthetic oil, or kerosene. So that is the process of liquefaction of coal. So you take the coal, you do hydrogenation, you obtain the coal liquid, or you can say you do the hydrogenation reaction and obtain the coal liquid. Once you get the coal liquid, you do distillation to obtain different kinds of fuel from that, or liquid fuel from that. So this process is called gasification. Liquefaction of coal. And this direct liquefaction of the coal usually happens through different kinds of process. Either it can be a single step process, or it can be a double step process. In case of a single step process, you have three different varieties. One is SRC2, and another one is Exxon Dona solvent method, and another one is hydrogen coal method. In case of the double step direct coal liquefaction, you either go for integrated two-stage liquefaction or catalytic stage liquefaction. So anyone who knows what's actually the difference between the single step and double step, or what kind of advantages do you get from single stage and double stage liquefaction of the coal? Yes, anyone? Or first, what could be the we specifically say direct liquefaction of coal. So then there should be something like indirect liquefaction of coal, right? So how does this direct liquefaction of the coal is, you can say, good compared, or better compared to the indirect liquefaction? Any idea? How is direct liquefaction better compared to indirect liquefaction?
It has a higher efficiency.
Higher?
Efficiency.
Okay. So there are quite a few points. So one thing is, exactly, somebody said it right. One is higher efficiency, and the other is higher octane number. How many of you know what is actually the octane number? I mean the proper definition. Again, when we discuss about this liquid, I mean diesel or kind of liquid fuels, this octane number becomes a important parameter or an aspect. Okay, kindly have a look at it. What is octane number? So that will be something that you would like to. I mean, yeah, it would be is something that is an important parameter when you discuss about the concept of fuels. I mean, liquid uh, fuels. So apart from that, it's going to have better carbon footprints and the kind of gasoline and then the oil that you are going to produce is going to be of better quality. So these are the advantages of the direct liquefaction over the indirect liquefaction process when we are discussing in terms of coal. So any questions so far related to what we discussed now? I mean, because we do not have much. So as I said, the single stage and the double stage process, each and every process and then their details are described in the course. So please have a look at it. Other than that, anything that you would like to know now, or shall we proceed further? Any questions? Anyone? Any questions? So, if not, oh, sorry. So, I'm going to keep the slides here. So, we are going to start with the questions now. So, what we can do is, since we are actually moving towards the questions discussion, so between this, let's take a quick break for not more than 5 minutes. If you want, you can go for the break and come back, or if not, you can actually look at these questions and then try to solve them. So I'll just keep it a little bit, yeah, so that both the questions are visible. So try to find out the answer for these two questions. We will resume our session by 6:04 or 6:05. So I'll keep the slides. Yeah. So I think we can start. So what is the answer for the first question? Identify the type of scrubber as shown in the following figure. Is it a venturi scrubber, packed bed scrubber, or a spray scrubber, or none of the above?
Spray scrubber.
Spray scrubber. Any other answers? So what is the advantages of this spray scrubber? Any particular advantage that you can actually think of? Or how does this spray scrubber actually work?
Venturi scrubber.
Yes.
Venturi scrubber.
No. So this is actually a spray scrubber. So the answer is spray scrubber. Now the follow-up question is, what is the, I mean, how does this spray scrubber actually works? You can actually see the diagram and then try to explain. I mean, I think if you see the diagram, it is clear. I'll just show. I hope the picture is visible, or I think let me, yeah. So this is the spray. So this is a spray scrubber. Question is, how does this work? So it's quite simple, right? So you have this dry gas inlet from the down, and water inlet is at the top. The water is basically going to be spray in the form of tiny droplets. So this dry gas and then the water droplet is going to come in contact. They both are traveling in the counterflow direction. They are basically going to come in contact. So when that comes in contact, the particulate matter that is present in the air is going to get dissolved in the water droplets and is going to get removed. The particulate matter is going to get removed. Once that gets removed, the dry gas is going to be more, what do you say? the dry gas is going to be more less dense, so they basically raise up and then go out as a clean gas, whereas the water droplets that are denser, or that gets denser after the absorption of the carbon particle, settles down at the bottom as slurry and then is basically taken out. And then you have a mist eliminator, so that the gas so obviously when the dry gas is going to basically come in contact with the water droplets, other than the removal of the particulate matter, there may also be a chance that this gases obtain moisture. So in order to eliminate that mist, you have a mist eliminator, and then the clean gases ejected out from the top, whereas a slurry is taken down from the bottom. So that is basically the working of the spray scrubber. And now if I put one more question, why is that this water is basically sprayed in the form of droplets? So as such, when you say water inlet and there are sprays, so they are going to spray, they are basically going to make water in the form of droplets. Question is, why is that extra provision to make that water as spray? Why is there is an extra provision to make the water as droplets? Anyone? Why water is in the form of droplets? Why the water is sprayed? Simple. So when you basically spray the water in the form of droplets, the contact, you are basically going to improve the contact between the dry gas as well as that of the water droplet, because the water is going to be in the form of small droplets, so their contact with the gas is going to increase. So that basically improves the efficiency of the cleaning up of that gas. So it's going to improve the efficiency of the particulate removal. That is why if you see in case of scrubber, the efficiency for a 25 micrometer particulate matter is going to be somewhere more than 95%. So in order to make the process more efficient, the water is usually sprayed in the form of droplets, so that it improves the contact efficiency, so that the particulate matter removal is more effective, and the overall efficiency of the process gets improved. I hope it is clear. Any questions? Okay, so if there are no questions, then let's progress to the next question. So you can see the picture on the right hand side. Now you need to let me know what operation does P and Q represents. I think it is not going to be possible. I think we cannot have both P and Q. So just look at this. So here you have P and Q. You are supposed to tell me what does this operation P and operation Q represents for. This is basically the coal gasification process. So if you see, initially you have coal, you do a pre-treatment, and then with the oxygen and steam, you basically let it into the gasifier. Once the gasifier does the gasification process, a raw syngas comes out, and then this raw syngas undergoes cleanup. Whatever the residue that is basically left over is transferred back to the gasifier. Then it again goes to a stage 2 gas cleanup where you can remove the sulfur. Once that process is completed, either there are two ways. One way is it basically goes for some sort of a liquid fuel or chemicals production, or other way is since syngas has CO and H2, you can actually separate the hydrogen gas using a H2 gas separator, and then either you can use it for hydrogen vehicle fuel, or you can use it for a fuel cell, and then basically the hydrogen fuel cell, and then you can generate electrical power. Or this syngas can be used for some operation to generate electrical power, or it can, what do you say, go to a waste heat boiler, and then the flue gas can be ejected out, and then it can go to another operation to generate electrical power. And whatever the steam that comes out can actually go to the gasifier to make the process more efficient. So basically that is the main aim. So what does this operation P and Q actually represents for? Options: gas turbine, steam turbine, gas turbine, pump, compressor, pump and a generator.
Option A.
Just option A. Okay. Any other answers? Just a second. Okay. Any other answers? One of you have told option A. P is gas turbine and Q is steam turbine. So no other answers. So option A is correct. One is P is gas turbine and Q is steam turbine. If you ask how to find out, so one easy way to find out is, so if you see this part of the flow chart here or the process diagram, you can see that syngas is entering inside a particular unit to generate electrical power. So syngas is a gas, right? It's in the form of a gas. So this gas should go and expand somewhere, or you can say the syngas enters into a gas turbine, expands there, rotates the gas turbine to rotates the gas turbine. This rotation of the gas turbine generates electrical power. So that's what you actually get out of here. Or if it is not used there, the syngas, or you can say whatever the amount of energy that is not being used up to expand the gas turbine, can actually enter into a waste heat boiler and then boil the water. Whatever that heated water is there, it can be transferred to a steam turbine. That steam, so once it enters into the steam turbine, it expands, and this expansion basically causes the steam turbine to rotate. So once that rotation happens, electrical power is generated. So you can look at the chart. So if you see here, the steam is basically being taken. So something Q is related to steam and P is related to gas. So a process where gas or steam is used to generate electrical power. The units could be either gas turbine or steam turbine respectively. So option A, gas turbine. P is gas turbine and Q is steam turbine. Any questions? Anyone? Or shall we progress to the next one? Okay, so let's move towards the next question. Okay. Which of the following statement is not true about gasification? Reduced CO2 emission, accurate combustion control, higher thermal efficiency, and none of the above. I think this is probably a very easy one. Which of the following statement is not true about gasification?
Option B.
Option
B.
I could not clearly hear you. Option is it option B?
Option B, sir.
B, okay. Please be careful which of the following statement is not true. So I want something that is false about gasification. So it's going to be, the answer is none of the above. So if you see, all these statements are true about gasification. You have reduced the CO2 emission, you have accurate combustion control, you have higher thermal efficiency. So none of the above is the answer for which of the following statement is not true about gasification. So you can actually look at this here. I think I should write it. Advantages of gasification. Hmm. So since they are asking not true about gasification, option A, B, C, all three are true. They are true statements. So obviously we are supposed to choose the answer which is false. So since none of the options match, it's option D, none of the above. Next question. I hope no doubts in this because it's a straightforward one. So let's proceed to the next one. If oxygen is replaced with air in the gasification process, the produced gas is known as syngas, coke oven gas, producer gas, and none of the above. This is very simple one, so it's a very straightforward question. If it is oxygen, then the produced gas is called syngas. Now we are replacing oxygen with air. So it's called, so the produced gas is known as anyone?
Producer gas.
Producer gas. Again, if you see the composition of nitrogen, I'm just going to write it again. It's going to be 45 to 55 percentage, and your CO plus H2 is going to be uh, I think approximately, just a second, 30 percentage, right? Yeah, 30 to 40 percentage. So this is the answer, producer gas. Again, these two questions, any doubt so far? Or shall we progress to the next one? Because these are direct questions. Okay. So let's move on to next one. Which of the following is not a direct benefit of liquefaction of coal? I think this is also a direct one. Not a benefit. So first option is higher octane number. Option B is high efficiency. Option C is low sulfur gasoline, and option D is high capital cost. What could be the answer? It is high capital cost, right? Because higher octane number, high efficiency, low sulfur gasoline, all are nothing but the benefit of direct liquefaction of coal. So the only thing that is not the benefit is high capital cost. Any doubts in these three questions? These three are very straightforward ones, so I hope there should not be any doubt. If you have, then let me know, or otherwise you can progress to the next one. Anyone? Okay, then I think I can move forward. So, the shift conversion reaction that takes place during the water gas manufacturing is given by the following equation. So, you are supposed to tell me which equation is which equation correctly represents the water gas shift reaction. Yes, it's water gas shift reaction. I'm just asking to name, the exact equation.
Option C.
Option C, carbon monoxide plus water gives carbon dioxide plus hydrogen. That is for water gas manufacturing reaction. So, option C. Any other answers or anyone else? Any question or confusion? Okay, then I think shall we move towards the next one? Because these are direct questions. No doubts? Okay. So, next question is which of the following solvent is used in the Selexol based absorption process? Is it methanol, methyl diethanol amine, or dimethyl ethers of polyethylene glycol, DEPG? So, in case of this syngas cleanup, one of these ways is solvent based approach, right? So over there we basically use multiple types of solvent to clean up the syngas. So the question is which of the following solvent is used in Selexol based absorption process? Is it methyl diethanol amine or methanol, or is it dimethyl ethers of polyethylene glycol, DEPG?
Dimethyl ethers of polyethylene glycol.
Okay. Any questions in this or any doubts in this? Answer is dimethyl ethers of polyethylene glycol. That is the Selexol based absorption process. Okay. So let's come to the next question and then we will actually get back to this question. We have to discuss more in this. So for the time being, next question, it is written MDEA, methyl diethanol amide, is used for physical absorption, chemical absorption, both A and B. So the solvent that you see here, methyl diethanol amine. Again, any kind of absorption process, there are two types: physical absorption, chemical absorption. Now now this methyl diethanol amine is going to follow which one? Is it physical absorption or chemical absorption?
Chemical absorption.
Chemical absorption. Okay, that is correct. Now, if MDA follows chemical absorption, what about this Selexol based absorption process and methanol absorption? Are they going to be physical or chemical absorption process? So
Physical.
this is yes,
Physical.
this is chemical absorption.
Water.
What about DEPG or also called Selexol?
Physical.
Physical absorption. And what about methanol? Or you can also call rectisol. Is it physical or chemical?
Physical.
Physical absorption process. Now, how does this each process vary? Or what's exactly the difference? Or you can tell me how does the composition of the flue gas after the treatment process vary in case of MDA, Selexol and methanol? So the composition is going to vary, right? So when you have this syngas and then when you're going to use solvent for absorption, after that absorption process, you're actually going to get clean syngas. But then the percentage composition will vary depending upon the type of solvent that you use. So how will that vary? So kindly have a look at that because that is going to be important. So if you see in the slides, after the solvent based approach, you have a table wherein it is written how will the hydrogen sulfide H2S dihydrogen sulfide concentration and then the carbon dioxide is concentration will vary depending upon the type of solvent that we use. So please have a look at that. Now I think I can move on towards the next question. Okay. Okay. So any questions? Anyone? Any questions? No? Okay. So let's move on to the next one. SNG primarily stand for. So I hope you are able to remember in syngas, the utilization of the syngas concept when we discussed about what are the different ways. So one of them is basically using the syngas for SNG. Now SNG primarily stands for supernatural gas, specific natural gas, substitute natural gas. Only three options. So it's called substitute natural gas. Basically, what it means is the syngas is used as a substitute for natural gas. That is the reason it's called as SNG, substitute natural gas. So this is just a definition. So I mean, sorry, kind of an abbreviation. So please remember this. Next question. Identify the process from the schematic diagram given below, or I mean given here. So what kind of gasification process is it? Is it an entrained bed gasifier, or is it a plasma gasification process, or is it a fixed bed gasification or a fluidized bed gasification? So kindly look at this gasifier. You will be able to find out the answer. It has what do you say? Uh, Voltage sign. It's an electric arc if you see what is getting generated. So it is plasma gasification. So as I said, voltage is applied to basically create an electric arc, and that creates a spark, because of which what happens is that electric arc generation actually generates temperature, and that temperature is basically used for burning of the coal. So that is what it is. Oh, sorry. This is plasma gasification. Any questions so far in what? Because next will be a problem. So if you have any questions, you let me know, or otherwise we will go forward. So no questions? Anyone? Okay, so let me move towards the next one. Okay. So the problem goes like this. Calculate the amount of work done in the burning of carbon in nickel-based CLC when the change in entropy is 420 Kelvin and working temperature is 400. Sorry, when the change in entropy is 420 Joule per Kelvin and working temperature is 400 Kelvin. And then the reaction is given. You are supposed to calculate the amount of work done. How do you go about this question? You have the work that is, I mean, the delta H values for the two reactions. You have delta S, that is 420 Joule per Kelvin, and you have the working temperature as 400 Kelvin. Any idea on how to solve this? There's a particular equation. So let me give you the equation. I hope you will be able to, some of you may be able to recollect what, probably because of equation you may not be able to solve. Q hot equals to Q cold plus Q naught plus T times delta S. Is this fine? If this lead is fine, will you be able to calculate? Oh, sorry. This is work. I have given that equation. Now, please try to solve. Q hot, Q cold, we know. Q naught we can calculate. From here we can calculate the work done. What is Q hot value? Please solve along with me. In case if you have any doubts, please let me know. Or if you have got the answer, then please let me know again. Because these kind of questions will come in your assignment or probably even in the exam. So better to practice solving as much as possible. So Q hot is 396 kilojoules, right? Because it is an exothermic reaction. So Q hot is 396. Q cold is 136 kilojoules. So that is going to be 396,000 joules. This is going to be 136,000 joules. Now, how will you calculate Q naught? Q naught is nothing but T times delta S. So that will be nothing but 400 times 420, because both are in Kelvin, the units. So what is 400? 400 times 420. 168,000 joules. So work done is, so if you plug all these values into the equation, then work done will be 396,000 minus 136 minus 168. So how much is that? 396,000 minus 136,000. Sorry. Minus 168,000. It is 92,000. 92,000 joules, or you can also write it as 92 joule, 92 kilojoules. This is the amount of work done in the burning of carbon in nickel based CLC. Any questions in this? Anyone? This is the primary equation. Q hot is nothing but Q cold plus Q naught plus work done. And then after that, it's all about just substituting the values. Any question? Okay, then I think, shall I move forward? We will solve one more problem. Okay, depending on the time, let's see, one or two problems also we can solve. Let's see. So I think I can move forward, right? So second question, in a gasifier, air flow rate and the feed flow rate are given as 10 Newton meter cube per second and 5 kg per second respectively. The municipal solid waste. So here, I mean, this is basically a question of gasifier. So the MSW waste contain no sulfur, nitrogen or chloride. The syngas contains CO 30%, CO2 5%, H2 as 35%, and CH4 as 5%, and C2H2 as 3%. Calculate the rate production of syngas in Newton meter cube per kg of coal. So you have to calculate the rate of production of syngas. How do you solve this? Anyone, how to go about this? I mean, you require a formula. So if you know that, then it's about plugging in again, as I say. So I'll just give out the formula. Please try to plug in the values and let me know the answer. So syngas production rate is nothing but it's equal to airflow rate times 0.79, the entire this thing divided by feed rate times 1, just a second, 1 minus So this is the formula for the syngas production rate. So you have airflow rate, you have feed rate, you have the compositions of CO, CO2, H2O, H2, CH4 and C2H2. So just plug in the values from the given question and find out the production, syngas production rate. I have given the formula here. So you just need to substitute the values. Any answer? I mean, anyone who has solved the problem already? I think this is there even in the tutorial too, I believe. So let me plug in these values. Airflow rate is 10. I'm not going to put the units right now. So into 0.79 divided by feed rate is given as 5 kg per second. I'm going to keep it as 5 times 1 minus CO is 30 plus CO2 is 5 plus H2 is 35 plus CH4 is 5 plus C2H2 is 3 percentage divided by 100. Here just plug in the values as it is, no need to convert it into fractions before adding because we already have a by 100. So don't substitute value of CO as 0.3 when it is divided by 100. So it's automatically going to take care of that. So my this thing is don't divide it don't substitute CO value here in this particular formula as 0.3, because otherwise you will be dividing it with 100 twice. So value will be wrong. So syngas production rate is nothing but 10 times 0.79 by 5 times 1 minus, so 30 plus 5, 35, 35, 35, 70, 70 plus 5 is 75, 78 by 100, so 0.78. So that will be like syngas production rate is equal to 10 times 0.79 by 5 times 0.22. So you can simplify 10 and 5 to factor of 2, and then 2 by 0.22 is 1 by 0.11. So the final expression will be 0.79 by 0.11, 7.181. So syngas production rate is equal to 7.181 Newton meter cube per kg. Any questions in this? Anyone? Or any questions related to what we have discussed so far? We will have these two questions again. This will be pending. So in the next live interaction session, we will try to solve them. But as far as of now, if any questions is there, please let me know before we conclude our session for today. So today we discussed about gasification and liquefaction of coal and how you can use them for your energy production. And then we basically solve some of the following problems of what was discussed in week's 2 course content. So and based on that, we also solved two problems. One is about the amount of work done in burning of a nickel based CLC, and another one is basically calculating the rate of syngas production. Any questions? Or shall we conclude the session for today? Anyone? Any questions? Okay, then I think I can stop presenting. So thank you all. So I think I can conclude this session. So thank you all for joining today's live interaction session. Our next live interaction session will be on 9th of August from 5 p.m. to 7 p.m. Same in the same Google Meet. So I take this as an opportunity to thank Professor Prasenjit Mondal sir as well as the NPTEL team for providing me this opportunity to interact with you all in this Sunday afternoon, or you can say Sunday evening. So I hope you are able to access the course content and then the presentations as well. So if you so let me just share the details again. So in the course content page, that is the technologies for clean and renewable energy production, July to November 2026, that course content page, if you go on the left hand side at the right bottom corner, you can see problem solving session. So if you click on that link, you will be directed to an Excel sheet where you can actually access this video, which will be uploaded to an YouTube. You can get the link of that YouTube, and then the presentation will also be made available, and you will have my email ID there in the presentation folder. So in case if you have any doubts, you are welcome to email me or drop your questions in the Q&A section. I will try to answer to those questions as soon as possible. And yeah, so thank you all for joining today's session, and I hope to see you in the next live interaction session. Till then, have a great week ahead. Thank you and have a great weekend. Thank you so much. Bye.